Hi, in this video, I'm going to talk about question number 2 of homework 11 of probability and stochastic processes course. So let's dive into the question. In question number 2, there we have some functions of V in part A, B, and C. And in the question, it has been stated that each of these functions may represent an autocorrelation function or a spectral density function for a WSS, a stochastic process. So we want to examine that if each of these can be autocorrelation function or a spectral density function or both of them. So let's focus on the first one. The f of v is equal to e to the power of minus uh, of the absolute value of v. Okay, let's go to my answer. At first, we want to just review what does that mean. What are the features and characteristics of the autocorrelation and the spectral density function of a WSS process, a stochastic process. Actually, we had this in the previous question that the autocorrelation should be even and R of tau should be smaller than R of 0, and its Fourier transform, which is the spectral density function, should be non-negative. Okay, so after reviewing these characteristics, let's go to the first one. As e to the power of minus absolute value of v is even, and it is smaller than e to the power of 0, we know that this and after doing the Fourier transform, we see that the spectral density is also non-negative. So this function can be an autocorrelation. And because e of minus absolute value of v is always positive, it can also be a power spectrum. Okay, for part B, let me check that my video is alright. Okay, in part B, we have f of v equal to the sine to the power of 2 of v divided by v to the power of 2. Because this is even, and sine to the power of tau divided by tau to the power of 2 is smaller than the limit when we actually converge tau to 0. We know that this can be an autocorrelation function. After calculating the spectral density function, and we see that this is non-negative, we know that this can be an autocorrelation function. And also, this can be a power spectrum because the value is positive. And let me check again. And for part C, we have another function. This cannot be an autocorrelation function because the Fourier transform that we have here, the 2 times sine of alpha w divided by w, is not non-negative. So this cannot be an autocorrelation function. But this can be a power spectrum. Why? Because the f of w is always positive, as you can see in the definition. So this can be a candidate for power spectrum. Okay, this was question number 2. Thanks for listening to me.